All right. Wow. (26C). Oh yeah. All right. It's one of those problems. It's a problem. Oh yeah, it looks yummy. I might be the only person in the room that would use that adjective for that. So this is the one that says e to the x equals 2, right? Eeks. The eeks function. All right. So on this whole problem, I don't want to see any decimals, to be honest. Right. Normally, I'd want to see. I'm going to ask you specifically if I think about it, but normally I want to see the exact answer, and that always throws people off. Like natural log of 5. Somebody who's got the calculator out? What's natural log of 5? I haven't got mine built into my hand yet. 1.609. 609, and it goes. How long does it go for? Forever. Give me a few more decimals, just to really throw you guys off.
437,912.
All right. Which one of those is the exact answer?
ln 5.
This is the exact answer. Yeah. A lot of people think that's the exact answer just because there's a lot of decimals, but it doesn't. It keeps going, no? That's exact. That's approximate. I don't care how long you go. It's going to be approximate because it never stops. Right? Ain't no party like a natural party. That was good. Anyway, so in general, if I ask you for the exact answer, that means what people will consider the non-simplified answer, but it's just the not approximated answer. It's the okay. So how would you solve this equation? Yeah, take the ln of both sides. They cancel, right? Because they're inverse functions, and you get y equals ln 7. All right. Well, what if I say, okay, what if y was x plus 2? Does the first step change? Does the first step change?
No.
What would you do then? Subtract 2, right? To get x by itself. All right. So who gives a crap what this is? You got to kill him, and then you deal with whatever's left, right? Yeah, I did. But my math is violent. In my head, I always envision these things as zombies that I got to kill. And I watch way too much Walking Dead, or I guess as much as possible, all of the episodes. So, what would you do to both sides? ln. You can't do more than how many exist, I guess, right? I'll watch more Walking Dead than exists. True fan. And then what happens? If these go away, then you deal with what's left over. Right, that's what you did here, so why would you do something different over there? Mathematical processes don't care what's in them. We do, because it tells me what I'm going to do next. But the process doesn't give a shit. Now, what's the process for solving this equation? Take ln of both sides. Oh, I already did. So who gives a shit? What is ln of 2? It's a number, right? I'm not going to take the ln of it. So take ln of both sides. So I get x is ln of 2. All right, cool. And of course, you could do e to the e to the e to the e to the e, and just be ln of ln of ln of ln of ln of ln. Cool, I like it. You guys with me? So I mean, it's the same thing as always. You just do the immediate thing you have to do, and then you deal with what's left. That's how it always works. Okay. So.
That's at number 4. I was just wondering if there was any more information.
Yeah, it kind of seemed weird.
Oh yeah, I like it. Sketch a rough graph of the yield of a crop. So there's a lot of assumptions that could be made, and I'll accept a few different types of answers, especially like your y-intercept. But if you just went out and found some ground and you just planted something and you didn't put anything extra in there, is something going to grow? Probably something's going to grow, right? What's the yield going to be? Probably not the best. Right? That's why people buy a lot of shit to help the yield be better. So the y-intercept won't be 0 necessarily, but you could argue that you could find somewhere where there be nothing. It's just barren. The soil is completely nutrient-less, right? But if you just found somewhere, more than likely it's going to start off somewhere. Now, if you add Fertilizer. Okay, good. Remember. So you add fertilizer, what's going to happen?
It's gonna go up.
Yeah, but is it going to go forever?
No.
If so, people just be like, keep on going. You're going to get giant apples. No.
It will eventually just plateau.
I like it. A plateau. And actually, at some point, if you add too much, like if you get stupid amounts of fertilizer, that's ground. It's probably going to be detrimental to the yield, right? Because then it's not able to get other things it needs. Does that make sense? So, I mean, you go, yeah, and you go, yeah. Something like that. That's all you got to capture is that. You with me?
Yes, sir.
So it's just, you understand how to create a graph that captures the idea of a physical situation. That's without any, I like it. You're like, do you need more information? No, you just go into it with what you know. If you don't know what the word yield meant, you can Google it, right? So I agree with you. That was one of the weirder questions on there, totally. But it's just, do you understand how a graph that you can create relates to a physical situation? Is that cool? So that's number 4, all about props and yield. Yes?
E and F of 10. E and F of 10.
Oh, good. All right. In general, if I give you the graph of a function, let's say I give you this. Let me make it different than what they got. All right, so how do I know that's invertible? Passes the hoot? Yeah. Horizontal line test. Good. The ham, lettuce, and tomato. So how do I graph? So its inverse must exist. So how do I graph its inverse? Yeah, how do you deal with from f to f inverse? Always. You switch the x and y. It's almost too easy to believe. So what point is that?
3 and 3?
No.
Negative
Negative 3, 3. And this is negative 1, 0. And this is 1, negative 1. And this is 2, negative 3, right? So what points does my inverse go through? 3, negative 3. You switch it. It goes through the point 3, negative 3. And it goes through the point 0, negative 1. And it goes through the point negative 1, 1. And it goes through the point negative 3, 2. So that would be my inverse. I wanted to give one that was different. The one in the book will be a little more interesting because, in general, if I give you a function, its inverse is going to be the mirror image across that line, right? And which makes sense because if you switch the x and y, visually it's going to flip over the y equals x line. Do you guys remember this? Is this coming back? So graphing an inverse of a function given the original function's graph is easy as hell. You just take the x's and y's and flip them. How do you solve for the function, the inverse function? You take the x and the y and you flip them. So you do the same thing with the graph. Cool. And so, and once you get 10e, you take that new thing and you shift it. What would f of x plus f inverse of x plus 3 do? It would take this black line and move it back 3. Yeah. That's the same thing you do. Once you get f inverse, you can move it around. I like it. I like it all. Is that cool? You guys all right? Bless you.
Thank you.
Okay. You guys look at me intently, but with like a blank, intent stare. All right. Yes?
Number 18.
Oh, good. All right. Somebody was asking about this earlier. What kind of function are you going to need to use for number 18? Piecewise. I love it. Right? It's not pennywise, not they float. Right? No pennywise. Thank you. All right. Piecewise means, I don't know why the wise is in there, to be honest, but it's defined in pieces. So you have one piece from -2 to something, and another piece. So in reality, you could have a rocket ship going up, and then it hits something, so it drastically changes course. So it has one function defined in the first part of it, and then at some point it changes to a new function. So you have to define what x values that a certain given function exists for, right? So this is just a line, and they give you the points. Easy. That's not easy, it's a problem, right? I think you're just concerned about the other part. But the first part is just find the equation, the line going from negative 2, 2 to negative 1, 0. You can all do that, right? Right? Yes? Okay. And then the other part, so once I get a line, whatever the line is, I've got to say it's for x from what to what? Yeah, from negative 2 to negative 1. So that's what it's defined over. Alright. This is number 18. So that's the first part. Yeah. Second part is going to be a circle. What's the equation of a circle at the origin of radius 1?
X squared plus y squared.
X squared plus y squared equals 1. If it was offset from the origin, what would change?
Parentheses.
Good. It would just be a translation in the x and a translation in the y. So you just have to do minus or plus, minus or plus, something, whatever. You guys with me? So it's at the origin, so it's minus plus 0. Okay. And it's 1, because 1 squared is 1. All right. It's good old Pythagorean theorem for circle definition. And they want the top half. How the hell does that go? How do those two go together? Well, I have to have something to put here that f of x equals, and of course f of x is another way of saying what?
Y.
Y. So what's wrong with this? It's not
Y.
solve for y. Just solve it for y. In the process of solving for y, you're going to do something mathematically which would normally require you to have two answers, right? Because when you take a square root, what do you have to put?
Two answers.
Plus or minus. They want the top half. That's all. Do you see what I'm saying? So to graph a circle in your TI calculator, or whatever the hell kind of calculator you got to have the y equals positive rad whatever, and y equals negative rad whatever, and then you get the almost complete circle. Very often it has trouble at the ends, resolution-wise. It has open endings, right? And it looks like Stewie's head because of the non-square window, right? Or football if you don't know family.
Unless you change the...
Exactly, unless you square the rectangle, yes. There's a way to change the window so that you can square the rectangle. All right. That's a phrase you didn't think you'd hear. Go square the rectangle. Excuse me. All right. You guys here? Hello? Anything else from homework? Yes?
I don't remember what it was, but I don't have an answer for it, so 25A.
Oh, okay. All right. So let me start off with asking a relevant but seemingly irrelevant question. Can somebody tell me what this is?
W.
Yes, because 8 to the power and log base 8 are inverses, right? And let me see what you guys can get us. What does that represent by itself? Does anybody know what that represents? What's a log always represent? What's the answer to a log always? What is it? And you guys are like, what the hell does this guy want from me? A number? Like, what is log base 2 of 16? Why? 2 to the 4. So the answer to a log is always a power, an exponent. I like it. So that is the exponent that does what to 8? Makes it W. So when you put it on 8, what the hell does it make it? W. Do you understand? Isn't that the exponent that, whatever this number is, whatever this equals, is the number that you put on 8 to make it become W. Isn't that what that represents? Like this represents the number that you put on 2 to make it 16. That's why the answer is 4, right? So if that represents the power that 8 needs to become W, what do you get when you raise 8 to it? You get frickin' W. You get what it said it was going to do. Does that make sense? Or else you just go, W, that's easy. Right? Because they're inverse functions, but it's really nice if you understand the other way to look at it. If you understand the other way to look at it, you understand logs a little bit better. But what do you need to do that problem? You just need to be able to cross through two things and then put the other thing down, right? Is that cool? So how does that relate to your question? Well, how would things change if I did this? They do change. Move the 3 where? You can't put it in front of the W. Yes, good. When do you multiply powers? When they had something being raised to a power, so that can go back up as a power, right? That's the property of logs. The most important property of logs is that, because that's what enables us to solve equations with a variable up in the exponent. Logs will bring it down. So I'd have to first put the 3 there. Now what's the answer? It'll be W cubed. So yeah, so in that problem you have to first get the coefficient out of the way. And then the two things cancel. You're done.
Got it.
Cool. I like it. I like it. You're not looking at me expectantly. And I'm returning that stare. Anything else from homework? Is that good? Did homework go okay otherwise?
Yeah.
Like, I haven't done it yet, but I'm going to do like this. Yeah.
17.
Oh, okay. What does even and odd symmetry mean? And what's a really easy way to remember? Does anybody know what even symmetry means?
The highest power is even.
Well, it means more than that. That's a way to remember it because it doesn't only reference polynomials. Any function could possibly be even.
It's symmetrical about the x-axis, the y-axis, one of the two.
One of the two, I like that. Is that your final answer? The y-axis.
The y.
Because you think about it, the way to remember it is, give me an even, the easiest even powered polynomial is x squared. And what's it look like? Sure. And what's it symmetric to? Y-axis. So any function that's even has to be symmetric to the y-axis. You guys would. That's what even symmetry means. I like it. I like it. Odd symmetry, you'd think it'd be x, but you'd be wrong. Too bad for you. Odd symmetry is symmetric through the origin. So even symmetry means it's symmetric to the y-axis. This is where the mirror would be. Odd symmetry means like x cubed. What's x cubed look like? Yeah, one of my colleagues says this is the giraffe graph because it looks like a giraffe, but I'm always like, it's missing its front legs. It's horrible. Little blood coming out. And the giraffe just goes, oh shit. Sorry. Well, if you had Corey, then I'm sorry. Giraffe graph is good for you. That's great. We're just going to laugh at it. So odd symmetry means symmetric through the origin. Like that. That's really weird to have a point mirror, but that's what it is. It's too bad. How you doing? So I want to develop a test that will work for anything. So what does this really mean? That means if this x has an output f of x, then so does what for even symmetry? What else has an output of f of x? Negative x. So the test is if I plug a negative x into f and I get this out, if it doesn't change it. Because what do you get when you plug a negative x into x squared? You get the same thing. So it's even. So if f of negative x is the same thing as f of x, then it must be even. Because does that say that means for all x? So there you go. It's symmetric around the y-axis. So what would it be for odd symmetry? If f of negative x equals negative f of x, then it's odd. So that's how you do the whole little section. You do this test. You just throw a negative x in and see what comes out. That's all you got to do. So this is number what?
17.
17, yeah. So for all those, 2 of them are polynomials, and 2 of them are not.
I think the last 2 is where I got kind of confused.
So anything with the x squared in it, almost, as long as there's nothing else in there really, something like this, you don't even have to do work because it's the sum of 2 even, so itself is even. If you have a mixture, then it's going to be nothing. It doesn't have to have either symmetry, does it? In fact, it's a little bit evil that I'd say this parabola still has symmetry, doesn't it? Right? Every parabola has symmetry. Just because it's moved over, you have a new axis of symmetry, right? It's just not officially even symmetry because it's got to be the y-axis. You with me? But so if it's like this, then that's still going to be even symmetry. If it's like this, that's no symmetry, at least not even or odd symmetry, right? There are other symmetries, but not one of those 2. Cool. But the one problem is like this. If you plug a negative x in, what happens? So f of negative x equals e to the negative x squared. What happens? So this negative does what? Cancels, but that negative is still there. So how does it compare to what it was originally? It's the same, so therefore it is evenly symmetric. I like it. Do you see what I'm saying? So if you have an x squared kind of like sitting anywhere in a function, it almost definitely will be even. There might be some other weird thing, but does that make sense? Still do the test, but you kind of know what's going to happen. And the other one is just, do you know what sine is? What is sine even or odd itself? What does sine look like? What's it start off at in the middle? Let's start off here in 0. 0. And then it goes like that, and it goes like that. Right? So what kind of symmetry is that? Odd. Right? This goes through the origin to there. Right? I like it. So that's odd symmetry. If I do this to it, if I do this, what would that do to the function? Lift it up 1. Is it going to still be odd? And it's definitely not going to be even, right? You guys? Yes? Okay. But you can still do the test. Just do the test. What's f of negative x? 1 plus sine negative x. And now you got to remember what the hell that is. Good. Negative sine of x. And that property of sine is because it's odd. So this would be 1 minus sine x. So is that the same as it was? No. Is it the negative of what it was? No, because the 1 is still positive, right? Yes? Okay. So what about this? What if I had x plus sine x? Is that odd or even or neither? Odd. Yeah, why? What happens when you plug a negative x in? You get negative x plus sine of negative x. And what's sine of negative x? Negative sine x. So is that the exact negative of what it was? Yeah. Yes, so it's odd. There you go. Cool. Because sine is odd. And what power is x to? 1. An odd power. So it's odd plus odd, which is still odd. Right? So, okay, good. You should always do the test, but you should realize you can kind of look at it like that and know what to expect. But do the test in case you're looking at it wrong. Right? It's a good idea. All right, how we doing?
So if you put in a negative x, and it still is the same, it's odd?
No. The reason this is odd is because the answer to this was the exact opposite. This is equal to negative g of x, isn't it?
Okay. If it's the same, it's even.
If it's the same, it's even. So it doesn't care what side of the y-axis you're on. It's the same. So that would be even. If it changes exactly to the negative of what it was, that's odd.
And anything else is not?
Anything else is not odd or even. Okay. It might be somehow otherwise symmetric. Yeah. If it was... Now, why is x-axis excluded? You guys can get this. I keep using this symbol, meaning that they have to be what kind of things? Functions. So why is x-axis symmetry excluded in this current discussion? Because if it was symmetrical with respect to the x-axis, it would not be a function. Yeah, good. I like it. But you can talk about x-axis symmetry for relations. They don't have to be functions. So the x-axis symmetry exists. It just doesn't exist when I'm talking about functions. All right. All right. Okay. All right. Here we go. Anything else left over? 6? Yeah, what have we not talked about yet? Let's see. 6? This one says, find the domain. So I don't know how you guys were taught domain, but if you say in English what has to happen, and then write that in math and solve it, you're done. It's just a question of solving it correctly sometimes. So what has to happen with a radical? And we're talking about domain, they'd have to be very explicit if they meant including imaginary numbers. They just said domains, that means real numbers. What must happen with this kind of a function?
Can't go lower than 0.
What can't go lower than 0?
Inside.
Inside. So the inside must be what then?
And that's greater equal to 0.
Yeah, it must be at least 0. For any even root, right? Odd roots can handle negative, so they can handle anything. You guys would. So if you say it in English, now how do you write that in Macish? What's the inside?
Greater than equal to 0.
Yeah, sure. So greater than equal to 0, and the inside is 16 minus x. Now the question is, how do you solve that correctly? The answer is not add x to the fourth and take the fourth root. That is bad. That's a bad thing to do. Yes?
Can you just solve it like we would if it was like equal to 0, subtracting the 16 over?
So polynomial inequalities. Oh shit. Factoring definitely is a good step. So how do you factor this thing?
Difference of squares.
Yeah, yeah.
4 minus.
X squared and then 4.
For a good first step. And then,
Another difference of squares.
4 minus.
of course, you can't do sum of squares, right? Not using real numbers anyway. That's all we care about right now.
So 2 minus x.
2 minus 6.
All right. And this is an inequality. So if you wanted to do this directly, you'd have to have several cases. Because how could this come out to be positive? This could be negative, and this could be negative, and that could be positive. Or this could be negative, and this could be negative, and that could be positive. Or this could be negative, and that could be negative, and that could be positive. Or maybe you have all, they're all positive, or maybe, oh my God, holy shit. So I don't know if you guys have ever been taught the right way to do this. You should have been taught this in pre-calculus. Where's it equal 0? Real number-wise. Where's it equal 0? Come on now. Where's it equal 0? 2 and negative 2. A little z on top for 0. Does this feel familiar? Anybody? We're going to be doing a few things like this with calculus stuff. So in between, now in general, if you have a continuous function, what's the only way it can change from positive to negative is if it goes through 0. Right? So if I put 0 in, what kind of number do I get when I put 0 in? What kind of number?
Positive.
Positive, good. That means it's positive everywhere in there. It's positive everywhere in there, because the only way it can change signs is if it goes through 0. Now, who remembers multiplicity? Not the movie. Ever seen the movie Michael Keaton clones and stuff? No? All right. You never seen it? Look it up. It's funny. That's multiplicity 1. That's multiplicity 1. So what's going to happen? It's going to change signs around there. You guys remember that? If it was multiplicity 2, it would turn. It would stay the same sign. Does that sound at all familiar to anybody?
No.
I got to look up your pre-calc teachers. You had me.
I had you in math 110, not 176.
Not 176. Okay, I feel a little better.
I had a rookie for 176.
I'm
first
sorry.
timer.
Oh man, somebody's got to be that, right? Sorry. But if you did plug a 3 in, what do you get? You get positive. That's always positive, right?
Right.
Positive times
Positive.
2 minus 3.
Yeah,
Negative, so it's negative. It changed signs, didn't it? Right? If you plug in negative 3, that's positive, that's negative, that's positive, so it's negative. So I do all that freaking work. It's multiplicity 1, multiplicity 1. It's going to change signs everywhere. You just have to do one test point there. I know I went quickly, but this is stuff you should know already. But now I can answer the question. Look how it's easy to answer the question now. I didn't have to get any specific values because all I care about is where the freaking thing positive or 0. So where's it positive or 0?
From negative 2.
From negative 2 to 2. Done. Right? So a lot of people try to solve this directly, but then you have to do multiple cases. It's certainly related to absolute value equations. We have the 2 cases. Well, this is a lot more cases, possibly. All right, so screw that. Just do it direct. Do it like this. Do it visually. This is more visually.
How would you get the range?
Oh, so the range is kind of nice. What is the biggest this could be? Think about it. What's the smallest this could be? Isn't that the biggest the whole thing could be because we're subtracting? What's the smallest x to the 4th can be?
2.
0. There we go. Can't be negative. So the smallest it could be is 0. Which would leave what? Square root of 16. 4 is the biggest G could be. 4 is the biggest G could be. Do you guys see that?
So from 0 to 4.
Yeah, exactly, because what's the inside, the smallest the inside can be is 0. So that means the smallest output is 0. So the range is from 0 to 4. Alright, cool. Maybe. Alright. Alright, good. So that's all the questions from chapter 1 stuff? Alright, so let's get back into chapter 2. And let's officially get into chapter 2, I guess. I'm going to do chapter 2 a little out of order. I finally figured out why students have some trouble with this. I don't like the order they do this in. So section 2.1 goes straight to using limits to look at slopes at a point. And I'm like, we need to first freaking talk about what the hell limits are. And that's what section 2.2 does. So I don't like the way they ordered this in this book. Right? I don't know if you guys are like, I don't even know what the hell any of this shit is yet, so just do it. Alright. Come on, math boy. So let's sort of like when you first learn how to graph stuff, what do you make when the very first time you learn how to graph anything? What do you make an XY table, right? All right. Hey, guess what we're going to do? So if I ask you now, first off, let's talk about what this means. So the way to read that is the limit as x approaches a of f of x. That's how to read it in English. The limit as x approaches a of f of x. Or the limit of f of x as x approaches a. Whatever ordering of that you can say. So you're curious about what are the outputs doing as my inputs are approaching this value, a, whatever it is. How you doing? So a specific example why you might need a limit to help you is, what if I had this? What you got, Jeff? I don't know. So we saw one like this before. This is almost like the one that was on the quiz, but it didn't have a limit on it. All right. So this is going to test your ability to use your calculator. It's also going to test, do you have a calculator with you? Right. If you don't, just sit there, stare at your favorite wall. We're going to first do this the really, really basic way of, I don't know what the hell's going on, so let me just throw some shit at this and see what happens. And then we'll try it a more algebraic way. So what do I need to do here? I want to know, what does it look like this function's doing? Can I plug a 2 in? You could try what happens when you plug a 2 in. 0 over 0, which is worse than undefined. It's indeterminate. I think I said that the other day, but some of you guys might already know that word. Somehow it's a little worse than undefined. Undefined still is a definite answer. That's infinity as an answer for limits. So you know the answer. There's no limit. It just goes to infinity. That would be 1 over 0 for it. It goes to infinity, right? 0 over 0 is like, oh shit, I have no idea. Could do anything. So that's a bad place to be. You don't know yet. So what do you think I'm going to do then? What other numbers am I allowed to use? I can use any other number except like below -2, right? So I don't want to know what it's doing when I get close to 2, so screw -2. I want to get close to 2, so we do exactly that. So I can plug like a 1 in, 1.5, 1.9. Do you see that? I'm getting close to 2, so I always love... Have you ever seen that old movie, The Blob, the 87? And so the guy did it wrong. Something landed, and it's weird. So what do? You don't want to touch the damn thing, but you're like, what the hell is that? So you get really close to it. Oh, right? You're really close, but you don't touch the damn thing. The mistake he made is he touched it and jumped on his arm, and the whole thing started. Sorry, I watched too many horror movies. So that's what we're doing. We can't go to 2 because this thing goes nuclear, right? So it blows up and does weird shit. So I get really close to 2 and like, oh, what are you doing? What are you doing? And I have to do it from both sides. So what about on the other side? So we can get a little closer, 1.99 maybe. And then the other side would be 2.01, right? And 2.1, 2.2, whatever. All right, so take a second and fill that table in for me. Or several seconds. And I'll show you, let me show you something nice about your calculator, if you have a TI. It's like ET. Just make sure everybody's sort of on the same track here. What do you guys get for the first thing? Over -1. So what's that roughly? Give me. This is okay to give me decimal answers. We got to get decimal answers so we can see what it looks like it's approaching.
0.267.
0.267. Does that agree with everybody? All right. And then 1.5, anybody have that yet?
0.258.
0.258. 1.9 is 2.251. 1.99.
0.250.
0.250, blah, blah, blah. So.
0.249.
You guys cool with this? Even if you're not doing this is simple, right? You just have to be careful when you put it in the calculator. Of course, you need parentheses around the top, parentheses on the bottom, because your calculator doesn't have eyeballs yet. Maybe the TI 8000 will, and then that becomes Skynet and the end of our right? Skynet, do this problem. No, human. So this big bar, we know that there's parentheses there. Really, when there's a big bar, the calculator can't see the big bar. You got to put parentheses. So I always hate when students set things up right and then they put it in the calculator wrong. I'm like, oh damn, don't do that to yourself. So this is just plug it in. And 2.01 again, sorry?
0.249.
0.249? It shouldn't come out negative, though. No, it won't come out negative. Right, because the top will be a little bit bigger than 4 in here. So the square root is a little bit bigger than 2, and that is a little bit bigger than 2, so it's positive over positive. And this would be something like 0.248. 0.241? 6? All right. So let me show you something kind of nifty about your calculator real quick. Some of you guys might know this already. So when you plug it in your calculator, all right, it's your square root.
X plus 2 minus 2.
X plus 2, right?
And then minus 2 all over x minus 2.
So that's how I have to put it in. Now, you guys have probably used tables before, but I don't know if you've ever used tables. If you go to table set right here above window, you can tell it your independent, yeah, exactly. Set that to ask. And what that means is, when you go back to table, it will ask you, what do you want for x? So then I can just plug the table in. 1, 1.5. Look at that shit. 1.9. So forth. 2.0. Let me just do this one little stuff. All right. You guys with me? Yeah. I know you know how to plug stuff in. So I want the idea is more important than the actual calculations. This is not Math 90. Right? So what's the idea here? Now, so do you see how I kept going, but I really, what I'm doing is this. I'm approaching 2 from below. I'm approaching 2 from above. Like that, right? So you can draw those arrows in so it kind of focuses you. And you can see the pattern, of course. We can make a really good guess. It looks like the answer should be 0.25, a quarter. The answer somehow should come out to be 1/4. That's what it looks like. You guys with me? A little bit. We cool? So there's going to be a lot of problems like this in section 2.1 and 2.2. There's going to be, especially in 2.1, I think, if I remember correctly. And both. If I graph this thing, it doesn't look very interesting. Because it's really tiny outputs, right? So we can zoom in on where we're interested in. We're interested around 2, right, for x? So let me kind of zoom in. I love zoom box. Make sure I include 2 in there. Bam! That's exciting. Now, if you try, I don't know if you guys know, you should know second calc value, and if you try to plug 2 in, look what it tells you. I love that. Look, I love that answer. Empty space. We don't know. So what you do is you can trace, of course. You can trace and get really close to 2. And you can see the same kind of thing the table tells you. Do you see what I'm saying?
Yeah.
So you have the visual, you have the table. They both kind of tell you the same thing. The visual, sometimes you don't want to necessarily graph that by hand, so I'd rather make a table of values. And then I can just see exactly what the numbers are doing. So how do we do this? So maybe the answer is 0.2500000007. I can't tell exactly. I feel pretty good it's probably 1/4, but this does not tell me the exact right answer. It gives me an idea of around where it is. You guys, but this is very often this is what a visual approach, which is what the table represents, gives you. When you try to solve a system of equations and the answer is 1.7239, you're not going to do it graphically. You're going to get close, right? So the algebra comes in and says, let me help you. You guys just missed all that, but sorry. I need help to remind me to turn that bad boy around. So how do I do this algebraically? So maybe remember what we did on the quiz. I know there wasn't a limit question, but we do the same thing. That's why I made that point about on the quiz. We plugged 2 in, it wasn't part of the question, but I just wanted to show you we could actually plug 2 into the end result that we got. So this is a little bit different than the quiz, I think, because the top needs to be rationalized. But in calculus, you can rationalize numerator or denominator, whatever the hell you need. So how do I do that? How do I rationalize the top? What do I multiply by? Conjugate, which would be what?
X squared root of x plus 2 plus 2.
So on the top I get x plus 2, minus 2 plus 2, so those cancel, minus 4, right? Over x minus 2 times this business. Gather. So this is x minus 2 and x minus 2 cancel. Is that cool? And then now, can I plug a 2 into the result?
Yes.
Can I? What happens when you plug a 2 in? What do you get? 1 over the square root of 4, which is 2 plus 2 is 4. You get 1/4, right? So that's the algebra saying, here's the exact answer. You're right with your guess. Good job, human. You guys understand what's going on?
Where did the 1 come from on top? I'm sorry.
Because these cancel.
Oh.
That's x minus 2, that's x minus 2. They divide out to be 1.
Was that 4 and a negative 4?
Say again?
X plus 2 minus 4?
I just didn't want to write it again. Sorry. So it's x plus 2, right? X plus 2 minus 4, which is x minus 2, which cancels with that. Cool. All right. You didn't react like I wanted you. That's all right. I'll be all right. So algebraically, there's a few things with limits you can try to factor and kill. You can try to do the conjugate. But look what effectively happened. What was the problem? What was the main problem? When I plug a 2 in, this made it 0, and something up here made it 0 also. But look what happens when I do this. The parts that made it 0, they cancel. Right? So that's the idea with the limit is, algebraically, I try to make the problems cancel. If the problems cancel, then I can plug the damn thing in. I don't have a problem anymore. Why does this work, though? So can anybody tell me, this expression, it can only do this if x does not equal... What can x not equal in that expression? It can't equal 2. Right? If it equals 2, what happens?
0 over 0.
0 over 0. Okay, so x cannot be 2 in that expression. So how does the limit get around that? Well, what's the limit never do? The limit doesn't actually get to 2. It only gets really freaking close. So it says, what does it appear like this wants to do? So there's an open hole there. There is. But where does that open hole go is the question, right? So in pre-calculus, hopefully, you dealt with asymptotes. But are there always asymptotes? No. Sometimes there's open holes. How do you know where to put the open hole? You should have done some simplification like this to see where it wants to go, and then you know where the hell to put the open hole. Right? So you can't plug a 2 into the expression as it is, but you can simplify it in a way, and then you can plug it in, see what it wants to do. So it wants to do, it looks like, this function looks like this everywhere except at 2. But at 2, it wants to be at 1/4. That's where it wants to be. If I made f of 2 equal to this, it would fill in the hole that this gave me, like empty space. It would fill that hole in perfectly. All right, maybe. Okay, all right. So there will be several problems like this where you just have to make a table of values to investigate the pattern to see what it looks like it's going towards. They are going to give you some graphs, and let's try some graphs out. And then I got a little handout that I want you guys to do. Let's see here. You'll be all right. So, freeze. Okay. So let me just see what you guys think about this. Because what did we have to do with that table? We had to make sure that we approach 2 from above and from below, right? So does that make sense intuitively? How many ways can x approach a number from both sides? You with me? So, for example, this first question, what did the little negative sign on the 2 means? From below. Beautiful. I want to approach 2. So as x approaches 2 from below, what are the outputs doing? Where are they going? So here at 0, where's the output? There. At 1, where's the output? There. At 1.5, where's the output? There. So as I approach 2, what value do the outputs approach? 3. In fact, in this instance, what is f of 2? 3. So that actually the limit equals the function value. It doesn't have to. So real quick, there is a limit as x approaches 0. There is a limit, of course, right? And it's an actual number that it looks like it's getting there, and guess what? It actually gets there. So the one we just did, it looks like it's getting there, but it didn't actually get there. It was an open circle. But the limit still exists everywhere here. What's the limit as x goes to 2 from above? So what are the outputs doing as they approach 2 from above? What are the outputs doing? Approaching what?
2.
They hit 2 at 3, right? And if you go past, if you get closer to 2, what are the outputs doing? They're approaching 1, exactly. I like it. I really want to make sure you guys see that. It's a weird perspective shift that you have to go through. Do you guys see how to look at that correctly? I always have people that are like, well, as it goes to there, it goes here. No. As it goes towards 2 from below, you follow what the function's doing to see where. So I follow what the function's doing. It looks like it's going to 1 as I go to 2 from above. All right, how does that? Does that make sense? Okay, all right. What about, so what do you think the limit as x goes to 2 is? Do you think that exists? What is it from below? 3. What is it from above? 1. Do they agree?
No.
So what's the limit as x goes to 2? It doesn't exist. Undefined. D and E, I like it. Not D and D, sorry. No Dungeon Masters or anything. Alright. How are we doing so far? Is that alright? I mean, this is kind of big. This is the underpinning of calculus, is really what this is. This is what allows us to introduce the first of two things we talk about in calculus. And we do a lot with them, though, don't worry. So f of 2, what's f of 2?
3.
What's f of 2? It's 3, period. That's where it's filled in. You with me? And then it jumps down here and goes from there, right? So this wouldn't really represent a physical thing well, because even if something hits something, it'd still have to travel over time. It couldn't just transport itself. Maybe this is spooky action at a distance, I don't know. Quantum mechanics. So what about this? What's the limit as x goes to 4? Now, see, be careful. What's f of 4? Does not exist. Undefined, really. F of 4 is undefined. What is the limit as x goes? What's the limit as x goes to 4 from below? What's the function's approaching? 4. From above? 4. So what's the limit as x goes to 4? 4. I really want you to understand. I don't care if that L is open or closed. The limit doesn't give a shit what's actually there. The limit just says, what's it look like it's going? It doesn't ever get there. That's the key thing with limits. They don't actually get there. So if that circle's closed, open, if it's filled in here, so f of 4 is actually 1, the limits don't care. They don't know. They don't know what's actually going on at 4. They say, what does it look like it's doing as I get closer and closer to 4? Does that make sense? So what the function value is requires a filled-in circle. What the limit is doesn't. It just says, what's it look like it's going towards? Well, it looks like it's going towards 4 from both sides.
But it has to be both sides.
Exactly. So you can have a limit exist. Like part A, we got a number answer, didn't we? We got 3. Right? So the limit can exist from one side, it can exist from the other side, but for the limit to exist, period, at no specification, it's got to exist from both sides, and they have to agree. They have to agree. I like it. Maybe. I've got somebody giving me a reaction. Thank you back there. The rest of you guys are just spooking me out a little bit. Yeah.
So for F, would the answer be 4?
Good. So f of 4 now. Okay, good. What's f of 4 though?
Undefined.
Undefined. I really need to separate these ideas. F of 4 is not defined. It doesn't go anywhere, right? There's no output for 4. But does the limit care? The limit is heartless. It's, I don't care. It looks like you should be there. Where is it? The limit has no idea. It doesn't even care.
And the reason that the F of 2 is 3 is because it has a...
It's filled in. That's it.
One of them.
Yeah, all that matters is it's filled in somewhere. Now, if it was filled in both, they couldn't even call it a function because then it wouldn't pass the fruit of blind test. But it's got to be filled in somewhere for the function value to exist, right? F of 4. Limits don't care what's happening at the point. They just care what's it look like as they get closer to the point. I like it. Maybe. So let's do this. I'm trying to leave enough time for this little field trip. So see if you can do these two problems. Let me do it like I do a test. There are actually 13 problems. Too big. Because I hate it when you have a teacher's like, how many problems on the test? 3, and then like they're all A through J. So the first problem on here is A through L.